Um, First of all, thank you for the organizing committee for this opportunity to allow me to stand here and present the work, even though this is not mine. But I think it's a good chance to interact with lots of experts here in this CCS field. And this presentation is made by Dr. Li, and he's a leader of Kanban Storage Research Group in China Academy of Science. Unfortunately, he cannot make it. So I was asked to present on behalf of him, not because I'm an expert in CGS. I think it's because I'm a Chinese and I can't happen and I happen to know him. So he just graciously sent me the presentation and I can stand here. However, I did some homework a few days ago just to learn more about this. Trying to make sure that I can present the information as accurately as I can. So the picture showing here is, I think, the photo taken by Dr. Li. That is the one, that's a concept picture from the first living temperature camouflage project in China in outdoor spacing. I think this is good achievement, a milestone in China, and to have this project actually in implementation. Um, ah, sorry, just changed too fast. Um, just few words to say where we are from. I'm from Trondheim, Norway, from the Department of Plant Geoscience at SINTEF Industry. And Dr. Li's group is located in Wuhan. And some of you may be familiar with this city because that's where the first breakout of COVID started. Um, Sorry about that. I can ignore. Um, Also, I want to take this opportunity to introduce my group, and my group is under my group is formation physics group is under the Department of Plant Geoscience, and in our whole group we have experts in different categories that were trying to develop um, different methods and equipment to have this advanced geological and geomechanical geophysical characterization and monitoring. And we also have some world-class laboratory and modeling facilities serving for various industries, including upstream oil and gas industry, CCUS and hydrogen storage, and also geothermal energy. And it's worth mentioning that we are also the world pioneers of CCUS or CCS. I kind of, I think I'm blessed to be with some of our colleagues who uh, first developed or this concept of CCS in Norway in 1980s. Um, of course, we also provided research to support the technical and the regulatory advancement through energy in green energy transition. Also, some words about Dr. Li's group, and his group is established in about 20 years ago. It's also the first, I would say, the one of the pioneering research group dedicated in carbon storage research in China. And they have various research fields, including multi-phase and multi-field coupling theories and technologies, as well as developing some testing and simulation methods. And they also step into this application of big data and machine learning relevant to the CCS. And in the following presentation, I will just go through these 4 points. I will just give you an overview of what is the current status of CCS in China, and also what are the 3 representative CCS cluster projects. And I'm going to introduce kind of example CCS projects collaborated with Dr. Li's group. And at the end, I will address this China's first offshore CCS project. Okay, so here you can see this big picture. There is a strong recognition and motivation in China that we need to have some significant reduction of emissions in this long-term plan. And just want to put into this, putting comparison with what we have been discussed yesterday on the scope of Europe on 2030. And here you can see that we are very ambitious, want to have even more, 200 million tons per year reduction by 2030. And in 2060, the scale is different again, will be above 1 gigatons per year. That's a big number. And because of the structure of energy consumption industry in China, I think we would most likely maintain our coal-fired power plants to generate power. So there is a high expectation of high contribution of CO2 from those power plants. So you can see in the first phase of this long-term plan, the contribution from the coal power industry would be very high. Um, but in the later phase of this plan, with the improved bio-CCS and the direct air capture technologies at lower cost, I think they were taking the dominant dominant in the whole picture, like to reduce the CO2 emissions up to 800 million tons by 2060. Also, I forgot to mention that at your left, sorry, right side, um, we can actually categorize these different industries into different groups according to how much um, each industry can achieve for CO2 emission reduction compared to how much is generated from this industry. So for the iron and steel, the cement industry, we expect to have a low carbon emission. And for the coal and gas industry, we have zero carbon emission. And for the last one, this technology will give us a solution to have a negative carbon emission. So where would those CO2 go? Here you can see the map. Um, so across China, you will see there's a lot of places that we can store the CO2. The theoretical geological storage capacity in China is above 1 trillion tons, and including deep saline aquifers, oil and gas fields, and other geological formations. And the biggest portion of the storage would be going to the saline aquifers, would be up to 2.4 trillion tons. And comparably, oil fields take a small portion, only with capacity of 20 mega 20 gigatons for oil fields and 50 gigatons for the gas fields. And of this 20 gigatons from the oil fields, 5 gigatons will be used for EOR. And here you can see the locations of the major oil and gas fields in China. And what is highlighted in red are the basins that are considered most suitable for CO2 storage. So in order to match the source or match the captured CO2 to the storage site, I think it's not new to most of us. We need to have this strategy of source sink matching. So here I just use the example of the emissions from all the coal-fired power plants in China. And you can see they are located mostly in north, central, and the southeast China. And for storage sites, we have some good storage sites in north and central China, but there's only limited space in the southeastern China. And that's actually the challenge because that's where the energy consumption is very intense. And also the big population there makes the selection of storage sites even more challenging. And so that's kind of limit our choice to select the onshore storage site there. So now the offshore storage sites are into consideration. So what we have progressed so far in this long journey, there are more than 120 CCS demo projects that have been put into operation and planned. And I think more than 60 CCS projects are now in operation with a capture capacity more than 4 million tons per year and injection capacity more than 2 million tons a year. So that's kind of send the signals that we still need to have more storage sites ready for those captured CO2. Um, but the good news is that I think some of our oil and gas and power industries are very motivated, and some of them are successfully built the million-ton CCS projects already. On what is the last one, actually, I also want to highlight at the end is we just have the first offshore CCS project in operation, south and east coast of China. Here it just shows three representative CCS cluster projects with a capacity more than 10 million tons per year. And they are located in where the energy consumptions are intensive. For example, in Xinjiang CCS cluster at the northwest China, uh, and also the area near the Shanghai, where the Sinopec just initiated a 10 megaton scale CCS cluster, and also at the southeast area near the Shenzhen and the Hong Kong area, we're trying to have this Daya Bay CCS cluster. And just a brief introduction of the Xinjiang CCS cluster. That's the first, that's China's first CCUS hub, in the Jungara Basin. And this area has a high concentration of large-scale emitters, I think mostly from the coal power plants. And the objective is to achieve 10 million tons per year CO2 storage for EOR, and another 10 million tons a year for saline aquifer storage into the saline aquifers, in the 5-year periods. Sorry, in the 5-year periods in 50 years. And now what is in progress is now they have this ultra supercritical co-power cogeneration and the renewable energy plus the million tons CCS technologies integrated into the demo projects. And they are all expected to be put into operation in 2025. The next one is the one near Shanghai area, where the SINTEF started this 10 million tons CCUS cluster. What is different from the last one is the source for this CCS project mostly would be from steel plants, chemical plants, power plants, and cement plants. And now along the Yangtze River, I think some of the CO2 receiving stations are under construction and some of them are ready to send to the storage pond. And 2 years ago, we had this collaborative study with SINTEF, Shell, China Bao, and Boss to further discuss the launch of the project. The last one is the one near southeast coast area, where the first 10 million tons offshore CCS project is going to be established. And this is collaborated with by partners of Sinuk, Shell, and ExxonMobil. So I would also show you some projects supported by Dr. Lee's group, and they actually conducted some studies in this I would say the first coal to chemicals CCS projects. The projects started 10 years ago, and we also already had 300,000 tons of CO2 injected into this saline aquifers 1,000 meters below the surface. And their research group are focused on how to have the careful monitoring and containment plan for the injection. This one is another site in East China in Sanli oil field, where they have this depleted oil reservoir. And what is special about this site is it has the first million-ton, 100-kilometer CO2 pipelines used to transport the CO2 to the storage site. And it has a capacity of transportation equal to 1.7 million tons per year. And they expect to have a storage of CO2 about 10 million tons in 15 years. And this another project from their group is trying to store the CO2 into different formations. One is into coal seam, and another one is into saline aquifer. If I'm not mistaken, I think the one into coal seam, they want also use that to recover the coal bed methanes by injecting CO2. So the last but not least is the first offshore CCS project in China, near southeast coast of China. It's called the NPing 15-1, and it's built by SINTEF, and it's already in operation. And now it has injected um it has injected 300,000 tons per year. Sorry, 60,000 tons CO2 into the saline aquifers. And on this side, what I learned is they have this integrated system to transport and to extract the CO2 associated with production and then separate and compress on site, then inject into another well to the storage formation. So which is, I think, very unique. Um, so I would say that all this information had in this presentation are from Italy. Um, if you have any questions, just maybe you can ask me, and I can write down and forward to him. Otherwise, you can also write email to him, which is here. Yes, that's everything. Thank you.